In this video, we're going to go over using simulations in Fusion 360. So the way that we're going to do that is we're going to click here where it says Design to change our workspace. We're going to change from Design to Simulation. So previously we've used both the animation and drawing, but here we're going to click Simulation. When we click Simulation, we see the different types of studies that we can do. So most of you will be doing a static stress, so that's applying some static force to your object that you've modeled. But you can also investigate thermal stresses, nonlinear stresses, different simulations, and shape optimization. These simulations use what's called finite element analysis. So it breaks the object into a grid and solves for the stress at each of the grid points. So I'm going to select static stress here and click Create Study. Before we start our static stress tests, we want to make sure that our materials are what they should be. So I'm going to click here where it says Materials and click Edit. And I can change my materials here. So right now everything's steel, but if I wanted to investigate a different type of material, I could click over here where it says Overwrite, and I could click some other material, so aluminum or bronze or really any other materials. Note some of these do not allow us to do static stress on them. So I'm just going to keep them at steel for now, but on your projects you'll probably want to change those study materials unless your object is made completely out of steel. Once I've done my materials, I'm going to go here to Constraints, and I'm going to add what are called structural constraints. So we need to constrain the object, because if we apply a force to something and it's not held on or attached or constrained in some way, it's just going to keep moving and moving and moving. So we need to constrain the object by kind of attaching it, grounding it, before we can apply any loads. So I'm going to go to Structural Constraint. I'm going to rotate to look at the bottom here, and we're going to constrain these two faces. So those are the two faces that would be attached to a cart of some sort. Or instead, why don't we change my mind. We're going to constrain this roller. So this roller is what's going to be constrained by the ground. It's going to be flat on the ground. So we're going to constrain that so it can't move through the ground and it can't really bend at all either. So we're constraining that one face. If we wanted to, we could constrain other faces in the roller and select those. But let's just select that one face for now to constrain. Once I have added my constraints, we see that they're added here under Contacts. I'm going to go Load, and for this problem I'm going to add a structural load, but I could add all these different types of loads as well. I'll go to Structural Load, and I'm going to click these two faces, maybe this one too, and I'm applying a load of the cart. Let's say our load is 100 newtons. For your project, you'll want to choose a load that makes sense for your project. So here we have 100 newtons. We'll click OK. And next we'll go to Contacts. Or first let's do our degrees of freedom view. So I'm going to turn on this view, and what we want is everything in our model to be green. So if it's green, it means that everything is constrained or attached to something that's constrained. But right now a lot of our object is red, which means it's just free to move about, and it's going to create problems with our model. So we'll go here to Contacts, and let's first try doing automatic contacts. So this means that everything that is within this tolerance, so 0.1 millimeter of another object, will feel that object. So let's try it at 0.1 millimeter and click Generate. When we do that, we see that everything turns green. So once everything's green, we've applied our constraints and our loads. I'm going to click here and steady. Or no, sorry, I'm going to click here on results. Or let's do our pre-check. So under solve, we'll do pre-check. And it says the study setup has all the information required. So I always like doing a pre-check before I run, because if something is wrong, the computer will tell me at that point. And then I'm going to click here where it says solve. And it says simulation model 1 ready. We can solve on the cloud or we can solve locally. It's up to you. I think I'll just click locally and click solve. The simulation may take a couple minutes to run, but once it's done, you'll get a screen that looks like this, and it will show your minimum safety factor. So here's mine, it's 15, but when I look at this object, wow, it looks like it is really deforming, and that's because this scale of deformation has been adjusted here so that we can see what the scale is. If I change this to the actual scale, we see that there's virtually no deformation. So let's save that as actual right now. We can go here, and this color map is showing us different things. So right now it's showing us our safety factor, but we can change this to show us stress. So we see our stress is really concentrated on the shaft right there. We can also see the displacement. So we see our largest displacement is here in the middle, but also that is so close to 0. And that's because our force was really, really small. So if we're using a steel roller, we're most likely going to have a much larger stress. So why don't we go here to where it says load case 1, click loads, and we're gonna find our force, and let's edit this. And let's change it from 100 to 1000 newtons. And then at that point, our results will get this little yellow warning sign that tells us that our results are not up to date. So we will have to resolve. So I'll click solve once again. I'm solving locally. If your computer is not very fast, you might want to solve on the cloud, and that will work better for you. Now we see for this simulation that our safety factor has changed slightly. Our safety factor has not changed, but our displacement has changed and is a little bit higher. By changing the materials, this will all change, but essentially what we're seeing is how this object is responding to the static forces being applied. So how this object is responding to a cart being on top of this roller. So you can do this for your project. You can constrain your object in a way that it would typically be constrained, and then apply a static load that is something that the object would actually feel. And if it's something like you're modeling a pencil and you model the static load of somebody, say, stepping on their pencil, some of us might have the experience of when you step on your pencil, it breaks. And that's because the plastic is not made to withstand that kind of stress. So in that case, you're going to have very high displacement. Note, Fusion 360 will not show anything breaking, and that's because this is all elastic deformation. So it'll show you if it's going to fail, and it will show you that by having a very low safety factor. So if your safety factor is here in the red or yellow area, that means that it's not a very good design. We want our safety factors to be in the green area. If it's in the blue area, it means that it's kind of over-designed and we could probably make it with less material and it would still work. So that's just an introduction to simulations using Fusion 360 that you will need to do for your project.